Done. Good afternoon and welcome again to this lecture of electronics. I guess we were studying practical of electronics. Myself, Dr. Andy Meshram, Head and Associate Professor, Department of Electronics, Sri Mathura Das Mohta College of Science. And now, today, at this moment, we are going to study about the practical which is called as the phase shift oscillator. Phase shift oscillator is oscillator which generates AC wave, sine wave. And this is the circuit which we have tried to design on breadboard. And these are the three capacitors and these are the three resistors. I guess it is visible to you on this screen, right? So these are the three resistances, and all the three combinations of capacitor and resistance are going to provide around 60 degree of phase shift, and total is 180-degree phase shift, and the rest of 180-degree phase shift is being provided by the uh, other output of this op amp. So we are using again TL084 op amp, which is having four op amps. We are using the second op amp over here, and three op amps we are not using. So we have connected this resistance to the non-inverting terminal and directly to the ground. And this terminal, this input resistance is connected over here, and we have connected a pot in the feedback portion, right? So this is the circuit for, say, phase shift oscillator, and we'll try to see these oscillations on the CRO. So this is a CRO, and here first initially we need to connect the power supply to this. So this is the power supply that we are supposed to use over here, which is supplying dual power supply, I guess. So this is plus 12, which is coming out of this. So this is plus 12. I'm going to connect it to pin number 4 of TL084 IC. Yes, I have connected it to the fourth pin, which is plus 12. And this is minus 12, which I am connecting it to pin number 11 of TL084. And this is the ground, which is over there. So it is to be connected to the ground terminal, which is supposed to be the lower line of the breadboard. So I have connected it to the power supply, connected the power supply to this circuit. We'll try to see it on the CRO. So we are using this X axis only. So I'm connecting this to the output. So this is the output, and this pin I'm going to connect it to the ground. I guess it is visible. So I've connected it to this, and just by adding or just adjusting this, we'll be getting the sine wave, as you are able to see over here. So this is the sine wave that we are having of the phase shift oscillator. So this oscillator is going to give you the sine wave as it is shown over here. And we can calculate the frequency of this sine wave by using the CRO. So we can take peak to peak volt, peak to peak distance of this. So it is 1, 2, 3, and I guess 3.5. And it is kept on point 0.5, 1, 2, 5, 10. So 10 microsecond scale it is being kept in the CRO, time per division. So 10 into 3.5, that is around 350 microseconds. And if you convert it to frequency, so I guess it will be around, uh, my students are sitting over here, and I was expecting that they should calculate for you. So, but I'll try. So it is 1 divided by 350. So it's around point two 0.00285. That is nearly equal to 2.85 kilohertz, right? So this frequency is around 3 kilohertz frequency. We have tried to design this phase shift oscillator, and it is showing you a very nice wave with a very high amplitude of, say, around 20 volt peak to peak. So the voltage is shown on the y-axis, and the time is shown on the x-axis over here, right? So this is the another practical that we are having it in the RTMNU Nagpur University SEM 3 syllabus of phase shift oscillator, and we have designed this phase shift oscillator by using the components over there. So these are the three RC networks that we are supposed to use in this. I guess this much is enough for understanding this practical. And if you have any queries, you can ask me. My students are sitting over here. I can show them. So all my students of same three are sitting over here. Uh, yes, uh, these are my students, and they are here to do this practical. Some more students are sitting on that side. So yes, these all are my students. They are from semester three and uh, BSc semester three, and they are going to perform these practicals in their practical examination. Okay, so this was the practical that we are having for say RTM in Nagpur University syllabus of SEM 3, and this is a phase shift oscillator. So the Barkhausen criteria can be can be implemented by using this pot, which is going to manage AV beta equal to 1, right? So that is the basic concept of an oscillator. Unless and until we have this voltage gain of the amplifier as well as the voltage gain of the feedback, that should be equal to 1, right? So AV beta should be equal to 1. Then only we will be having these sorts of oscillations. These are the AC cycles that we are having. So this peak to peak voltage is around 20 volts, right? So it is showing a very nice voltage as well as the frequency. They are very fine, and they are not damped actually. So they are pure sine waves. And this oscillator circuit can be used to generate frequencies, different frequencies, by just changing the combinations of RC networks. So I guess this much is enough. If you have any questions, you can ask me on this. Students, if you have any questions, you can ask, or else if you have any queries, I'll be uploading this video on my YouTube channel. If you have queries, you can put it on my comment box of my YouTube channel. uh, so watch out for my YouTube channel. I have uploaded many videos, and still more videos I will be trying to upload it on the YouTube channel. Please go through that. Like, share, and subscribe my channel. Thank you very much. Stay tuned. Stay safe, and take care. Good day. Have a nice day. See you in the next session with the next practical. Thank you. Have a nice time. Bye. Good day.